Welcome to the live stream. This is Jared with Longboards. I'm in the process of getting ready to remachine all of the tooling, including the mold, the part fixture for CNC machining boards, and the boards themselves for Nelson Longboards. This is kind of a reboot. This is something that was brought on by a fellow named Q. I don't know his last name yet, but he is he's doing the logistics behind some of the reboot, and he's going to be propagating these boards, selling them, buying some of them, and we're going to be building them here at Longboards. So the first step is to take this take this file, which is a surface file, and then we've also got on top of that some shapes. Let's put this in the little wheel well. So here are all the lines associated with these cut files. We got a DK shape, an SK shape, and a no kick shape. So first things first, I've imported all of the shapes. I joined all of the edges, so we've got a DK, an SK, an NK, and a bunch of holes. Let's just group those together real quick. Group. No. Group. These two, we could group them, I guess. These rectangles are going to be what becomes the flush mount for the board. And so I'm going to start with the double kick, just because it's the big one, I guess. Let's keep the holes available at the moment. Deselect all of these, and I do believe these bigger wheel well shapes are the ones that were meant for the double kick, although I could be wrong on that. So first things first, we're going to turn this surface into a solid instead of just a surface. So I'm going to do two surfaces. We're going to do a simple wheel well render first, and then I might get in there and actually design a wheel well with curves and whatnot instead of just a simple extrusion. But we're going to offset this. Let's see here. Offset surface negative 0.25. It's got to think about that long and hard. Actually, let's go back. I'll do that again. I will not make it a solid. So I have another one to offset again for the bottom half, and then I'll do the same thing, except this time I'll turn that one into a solid. So that's the top half of the board. That's the section of the board that's not getting a wheel well cut. This section is going to be getting a wheel well cut. We're going to keep this solid for now. So we'll take the shape, now that we have two individual surfaces, we'll take that shape and we'll project it onto one of them at a time. So project. We'll group those two together. We'll split this surface with each of these. We'll take this and we'll project it on to the remaining surface. Group them together. Split that surface with, I think I selected the right one there. We'll see once it's done thinking. Yeah, it might not be happy about whatever I just told it to do. I'm just going to try and escape out of this one. I think I may have selected the wrong surface, or the wrong, yeah, okay. Let's see here. So it's going to be that one and that one. So we're going to split those. I think I chose right this time. See what happens. These are some really complicated surfaces. There are a very large number of triangles involved in each one of the surfaces here, so it's very hard to see through. I'm going to escape out of that one. So I'll get rid of this group just so that I don't have it anymore. We'll split that, use that group, right click, and it should be split now. Great. So we have two surfaces. We can blend curve is what it's called. Oh, you know what? We got to go backwards in time here. Okay, we need to fix up this. We need to fix the vectors. Yeah, see, the vectors are multiple pieces. Actually, I'll just take a line. We'll split the vector up. Oh, I need to send a link to Q so that he can watch this. While we're waiting. I wish I could play the music for you guys that I'm listening to in my ears without YouTube taking my channel down. So we're going to go through and analyze this curve, and we're going to find areas that are not cohesive, like that one. So that line needs to be there. Let's see if we can find another one like that. Looks like we have another one right there. So this is vector repair. If the vector has any non-parallel, non-tangential, tangential joint areas that are, wow, that's interesting. Okay. Areas, then when you project it to a surface and split the surface with that curve and then try to do a join or a blend curve function, then what will end up happening is it won't work in Rhino. So the problem that I need to fix is just that. I need to make the vectors fully parallel throughout, or tangential. So backing up here, it looks like maybe that's good. So I'll just delete this line here. We'll look for another imperfection. So that's probably going to be another one, maybe. Yeah, looks like we might be good there. Potentially parallel. Yeah, I'm going to call that parallel. And let's do this. Let's just take units, go into the units page, add a 0 here so that the display precision is actually what it is. And then let's look through the rest of this. Looks like we might have, let's go to a perspective view. Sometimes it's easier to actually see these things going on. So that's obviously, that may be right actually. Okay, Rhino let me zoom all the way into it and past it, which oftentimes means the math makes sense. It doesn't look to be any jagged edge corners here. So maybe just that one that we fixed already is good enough. Let's make sure they're joining properly here. Just put a big long line straight out as a 90-degree angle. Yeah, it looks good there. Do the same thing here. Okay, that's fine. I need to turn grid snap off. Okay. Looks like we're all paralleled up. So the way to figure it out is to remirror everything. Go back over here. Oh, did I delete the surface file? Okay, so I'm gonna have to. Okay. Oh, that's the bottom surface. Well, I think what I'll have to do is a workaround for my own mistakes. I'm gonna export this real quick as a DXF. Nelson lineup. Batray. Okay, I'm gonna close this. Okay. I'm not saving it as anything. I'm just gonna reopen that same file. Wow. When I'm streaming and I have a Facebook tab open, as well as 3 instances of this program, Aspire, which is our cam software. The computer takes quite a lot of time to do anything. Even though I've got dual 1060 graphics cards in this, I think my RAM is very, very lacking. I've got 8 gigabytes only. Okay. Go back in here. I'm going to close the other instances of this program I have running. My bad. This is a horribly unprofessional stream. Oftentimes you find that you've made a couple steps forward and then you have to go back. This shape is just one I put in there. Here's some topography lines that show kind of what's going on. This is the same Nelson mold that has been used for, I do believe, the last couple of years. And we're just rebooting it. We're going to keep everything the same. We might do a little bit of a change to the wheel well cut path so that it's not just a full plunge wheel well throughout, but rather like a gradual blended surface. I got that there. Here's the surface we need. So I'm just going to make a copy. And then we'll work off of the surface. Okay, back to where we started. Oh, and then I'll import. No, we don't want to insert. We want to import all these files. Great. Okay. First things first again. Offset surface, negative 0.25. Oh, is it going to build a solid for me? Yeah, it did. So let's go back and do that again. No solid. And we'll do that again. No solid. Okay. We have the top of the board, we have the middle of the board, and we have the bottom of the board. We'll take this shape here. Oh, we'll join these vectors together. Okay, one closed curve. Gonna run an offset. 0.063. Another offset, 0.1875. Those will be the two surfaces we actually use to project onto these. So that's the bottom one. Project that onto both of these. I'll group those together. I'll take this one and project it onto the top and the next one down. Okay. Oh, let's do that again. Group them together so that when we split this, we can split failed. Oh, I gotta ungroup it again. That doesn't work with grouped. Okay, this surface we will copy and paste a new one on, and we will oh, you know what? I'm going to go back a little bit. Okay, we're going to go right there. We're not going to do any blending. We're going to do just a straight blend with all the... I was going to include the rounded rail on the bottom and a slightly rounded rail on top. It's a beautiful shape though, right? I mean, look at that. Tons of concave in the kicktail. So, okay, I'll take this guy, copy and make a new one. This one and this one need to be split by this one and this one. Oh, did that split fail? Okay, we'll do one at a time. Cool thing about Rhino is that the right click often functions as, it might be the same way with other programs, but the right click also functions as enter. So, okay, now these, here, let's turn this and this. We'll blend that surface. Oh, look at this. Wow. That's some wacky ass shit going on. Okay, cancel that. So if I select blend surface, oh, I see. So then I'll have to select both sides. No. Interesting. It's trying to blend both of these surfaces. I've got to go back again. Maybe I can join them here. No, they already are joined. It's a single poly surface. Well, okay. So somehow this here edge does not want to stay true. The surface blend feature, I do believe it has something to do with this surface having been originally two surfaces. That's this line here in the middle. So if I project that onto that, I'll project it onto both of these. And then if I split this surface with that line that we just projected onto it, and that one as well, if I go trying to blend this surface, I select here and it only gives me half. And if I select here, it gets the other half, but the problem is it tries blending them at the same time. Yeah, I don't want to do that. I'm at a loss actually. I think I need to get this surface as a single piece. Yeah, we're kind of up shit creek. Okay, I won't be able to blend this surface. I'll do this. Okay, we have all three. I'll take this one, I'll run an extrude curve. We'll go up and down both sides. We'll select all three of these guys. We'll say, well, let's just do two at a time. So those, and we're going to run a Boolean Boolean Split with this guy. Did it cut the middle out? It's just, okay. Okay, now we have a salt. Oh, it's giving me some interesting. Working with other people's CAD files gets to be a difficult thing. Okay. We're gonna go back, undo the Boolean split. I'm gonna just try to Boolean two objects here. Let's see what this does. So it gives us that option. That's more like what I was going for. Yeah, those two options. So take this. Okay, it got rid of. Okay, if I just split these, you know who I need? I need John Gallic in here to tell me what the hell I'm doing wrong. Okay, getting rid of the edges there. Split this. Use an X-ray view, and we'll split it with that and that. Okay, now we have a solid. Okay, that took a minute. Just have to join these together. So three surfaces or polysurfaces joined into one closed polysurface. Took a while, but we have that one. We'll start the process over again. Extrude that surface. Select it. We'll split it with this one and that one. So we end up, okay. Okay, those are both closed poly surfaces now. Now we don't need the shape for a minute. I guess we can do the holes. Yes, okay, we'll delete that group of holes. Oh, we got an interesting thing going on here. Wonder if you can select a hatch. Can you extrude the hatch? No, it's a curve. Oh, these curves are all broken now. That often happens when you import shapes and files in from other processes. I do believe that Rich made these files in SolidWorks. First, interesting. It won't let me join those curves together. Oh, there we go. Joined them into a closed curve. We're going to get rid of these hatches. Huh. It says 11 closed curves. Oh, right, because I already had one joined. So. Okay. We'll group those together. Bring the surface back in here. Extrude them. Great. Boolean split. Intersection, I mean. No, difference. Boolean difference. So we have holes. We're going to use the wheel wells big 2D. Just select all those objects, join them all together, extrude, curve. We'll take this surface, Boolean split. We'll try a difference actually. We'll use all of these. Okay. That worked out. It took me a while to get it, but now let's draw these flush mounts. That's assuming we're going to use a straight cut bit for this wheel well, but we're definitely not going to be doing that. Well, first of all, I will use a ball nose. Flush 2D. Get rid of this. Look at the holes. I'll just make a copy here. Let's make a new layer. Call it flush. Oops. Flush curve, I guess. Copy that onto this layer. Fill it. We'll fill it this one, 0.25 inches, and this one right there. And do the same thing over here. Now we're going to be running, I guess that's going to be probably right around 2.25 inches. That works. Move that out 0.25. Move that out 0.25. Let's change the grid here real quick. Make snap spacing 0.25 inches. Minor line spacing 0.25 inches. That allows us to see a little bit better. Okay. Oh, did that? Okay. Well, we could have just made a, let's just make a 3D object here. Negative 0.375. We'll fillet edge that one. 0.25. No. Do the same to this whole bottom since it's a ball nose bit that we're using. That didn't like that. Maybe I'll just try one at a time. Oh, hey. I actually don't know how to do that. Yeah, it doesn't want to do all of it at the same time. All we really need is this little area here. Oh, wait. I guess I do want all of them to. Oh, you know, I did it. I guess it matters what order you select them in. Oh, it didn't work. Okay, I'll try it one more time without that long edge. It also did not work. Well, odd. Here I am learning. Well, we're just going to use that. So let's go back to the surface file. Let's turn on an X-ray vision. Okay, we're going to grab this. We're going to move it up 0.05 maybe. We're going to move it 0.01 back towards the board. Mirror that across this here. Take that one and that one. Do Boolean difference. We're going to use a Boolean split. Put this on another layer called flush surface. Oh, we need to go down a little farther, don't we? Okay, we're going to take both of these. Just make a copy of that deck so that if we need to go back and do this again, we can. Move those a little closer to the board. Let's just see what 0.02 inches does. We'll try 0.005. Let's just run an intersection. See what the intersection looks like here. Oh, okay. Well, there's some irregularities, but we can come down a little still. I'm just going to go a little farther than I need to. Moved it down 0.01. Now it's definitely below the surface. My tendency would be to actually flush the whole entire surface, but yeah, there's some little issues with that, but we'll go with it. Take these two, Boolean Split with that one and that one. Interesting. Some micro differences in the way the board is. Well, hey, though, that's our DK. I think when we design the wheel wells for this, we can go somewhere in that neighborhood, just kind of go straight in there. Well, let's see. I'd probably come down here like to there. Very cool. I like it. I think what we'll do next is just save the file and move on for the day. We're going to reboot Nelson Longboards, and at least we're trying to right now, among a bunch of other things I wish to be able to tell you about, or hope soon to be able to tell you about. For now, I'm going to check out, sign off, and talk to you again soon. See ya.